In this video, I will show you how to create 10 most common types of plots that you will frequently encounter using a new Python library called Let's Plot. We'll create several kinds of plots, ranging from scatter plot, line plot, histograms, violin plot, bubble charts, and many others. Let's get started. If you haven't already, then you need to install this library using pip install let's-plot. And once you have installed that, you are ready to go. For this demo, I've decided to use this cars dataset, and I will load this in a pandas data frame. So the dataset looks like this. Here we have details about cars. There are different attributes such as number of cylinders, miles per gallon, horsepower, the date of manufacturing, the origin, and so on. So here I'm importing the Let's Plot library. All of the functions that are available in Let's Plot will be imported and can be used. And since we are running this on Jupyter Notebook, we have to call this setup.html function. So let's run this. Now we are ready to plot. The first plot that I want to show is scatter plot. This is the most common kind of plot that you will see, and this is usually used when you want to show correlation between any two numerical variables. And also I'll introduce you to the Let's Plot library and how to use it. First thing we have to do is call the ggplot function. This will create our base plot where we can add different elements like lines, points, and so on. And here the first parameter for ggplot function is a data frame or some kind of data. It can be in dictionary as well. And if we just run this, nothing will happen and it will complain no layers in plot. In Let's Plot library, which is inspired by ggplot library in R programming language, the idea is you create a base layer like this, and then on top of this you add subsequent layers like points, lines, and so on. Since we want to show points in the plot, right, the points are derived from the data itself. And in ggplot, how you configure this is using something called aesthetics. So for this plot, I want to show in the x-axis horsepower and in the y-axis miles per gallon. So what this is saying basically is for this plot, x-axis should be the horsepower and y-axis should be miles per gallon. And these names should exist in the data frame that we just passed here. If we run this, we still get nothing. It still says no plots, no layers in the plot. So now we need to add a layer. We do this by adding a geometry. So basically this is a layer that will use the aesthetics that we define here and then plot it. And when we run it, we can see the plot where in the x-axis we have horsepower and in the y-axis we have miles per gallon. And from this plot, we can also see that as the horsepower increases in the car, the miles per gallon also decreases. As I mentioned, in the plot, you can add many layers with many elements of the plot. So let's see how we can do that. First, we define the base layer again using ggplot. And we define the aesthetics here in the x-axis again, same horsepower, and in the y-axis we have miles per gallon. Next, we add the same geometry point with color origin. Let's run this. So now we see the same scatter plot, but now it's also colored based on the origin of the vehicle. And here what's happening is in the base plot, we define the aesthetics with the x-axis and y-axis configured, but this layer inherits the aesthetics defined on top and adds the additional aesthetic called color, which should be based on the origin from the data. And the Let's Plot library will map every unique value in the origin to a certain color, and that's how we see it. We can add as many layers as we like. So let's draw a line. We can use geom smooth function, and this will draw a line that shows the relationship between these two variables. And as expected, the line goes downwards, meaning as the horsepower increases, the miles per gallon decreases. Now let's look at another type of plot, something where we combine both the line and the bar chart. So before we plot this data, let's create another data frame where we aggregate the average horsepower and average miles per gallon every year. So let's call this df2. Here I've aggregated the data so that for every year we have average horsepower and average miles per gallon metric. So we'll use this data frame now to plot the line and the bar chart together. Once again, we use the ggplot function to create our base plot and then define the aesthetics. So in the x-axis, we'll use the year, and in the y-axis, we'll use the average horsepower. We can either define the arguments like x equals to year and y equals to HP, or we can also just ignore because the first two will be x and y. Now let's add another layer for plotting the bars. If we plot it like this, we'll see something like this where for every year we have the same value in the y-axis, 1. By default, geom bar will try to count the number of rows in the data frame. But since we already aggregated the data and for every year we only have 1 row, right? So all of them have 1, but this is not what we want. So in that case, we just say stat equals to identity. This means we're telling the let's plot library that don't do any transformation on the data, just plot it as it is. And now we can see this plot where for every year where we can see the average horsepower. Let's make this a little bit nicer. So we can specify fill equals to some color. So instead of blue, dark green, and there's also a parameter called alpha, which is also known as opacity. So if we set to something like 0.7, it looks like this. And now on top of this, let's add another layer which shows the average miles per gallon for every year. So here we added another layer called geom line. And this geom line will override the y-axis with mpg instead of the horsepower. Here for the base layer in our plot, we specified year should be in x, and in the y-axis it should be horsepower. But for this layer, it will override what was specified before and then instead plot the miles per gallon. So now we have the line, the point, and the bar as well. So if you notice one thing, in the x-axis, the labels are a bit weird. So by default, the let's plot library treats this as a numerical value or a continuous numerical value. Let's just change this to discrete. And you can do that by calling the scale x discrete function. So now the labels also look correct. And if we wanted to change some properties of line or point, we can add, for example, size to be 2. It will be thicker. And let's also increase the size of the points. So you can add as many layers as you like and as many kinds of geometries as you like. Now, another kind of plot that we can create is something called connected scatter plot. So this is a kind of plot where you can show how two variables are changing over time. And this is also fairly straightforward. So again, we define our base plot using our aggregated data. So in the x-axis, we'll have average horsepower, and in the y-axis, we'll have average miles per gallon. And then if we just plot geom point, we'll get something like this. But what I want to show here is over the years, how did this change? So I want the lines to be connected between each point, and I also want an arrow showing the direction. So what we can do is use the function called geom segment. So this geometry will try to connect the points, right? It will draw a line between the starting x and y coordinate and the ending x and y coordinates. And the starting x and y coordinates are already specified here. So average horsepower and average MPG of any given point is the starting point. And now we need to define the end point as well. There's a property called xend. We can override the values here as well. So in the base layer, we define df2 as our data source. But for this specific attribute, we can also provide our own custom value. So in this case, I'm going to get the average horsepower value from the next year so that the arrow can connect from this year to the next year's average horsepower and average MPG value. So we do this by calling the shift function and providing -1. So here we have the xn and yn properties defined like this. And one thing I forgot before was we also need to add this aesthetics. And if we run this, we get the following kind of plots where the points are connected with a line. But this is still not something what we want. We want the arrows from every point to the next point, right? And for that, we can override this property called arrow. And notice that this arrow property is outside of the aesthetics definition. And we just call the arrow function. And now we can see the arrows pointing towards the next position. So from here to here, from here to here. But this is still not clear. Like we want to also show the year of each of these points. So let's define another layer, geom text with aesthetics, and label will be here. This is still not clear enough because the points are overlapping. So what we can do is nudge the label a little bit towards the right. We'll do something like nudge x equals to 4. So in the x-axis, the text will be shifted. So this is a little bit clear, right? So from 1970 to 1971, the average horsepower decreased, but the average miles per gallon increased. And similarly here, from 1979 to 1980, the average horsepower decreased quite a lot, but average miles per gallon improved. So this is how we can show the relationship over two variables over time as well. Next, let's look at bubble chart. So this is a kind of chart where you increase the size of the point based on some additional property of the data. So up to here, this is pretty standard plot, right? So we have the scatter plot that we saw before as well. But now I want to increase the size of these points based on some different attribute of the dataset. So in this case, let me specify that the size should be dependent on the weight of the car. So as we can see, the size of the points changed, but this looks kind of ugly and it's difficult to see what's going on here. And usually when you create a plot like this, you generally want to decrease the transparency so that you can see the data points behind these big circles as well. And we have already seen that we can use the alpha property to reduce the transparency. And now this looks much readable. So you can see the points behind the big dots as well. And based on this transparency, you can also see where most of the values are concentrated around. So many vehicles are around this 100 horsepower range and 150 range. The next plot that I want to show is called heat map. Basically, when you have two categorical variables and you want to show the pattern between these two variables, then you use a heat map to convey your message. So here, let's plot something that shows the average horsepower for every country in every year, right? So this is a kind of data where we have year and origin as two categorical variables, and the average horsepower as a numerical variable. And we'll use these three attributes of the data to create a heat map. So first we need to aggregate our data. So here I've aggregated the data based on year and the origin, and then calculated the average horsepower. So we'll use this data to create a heat map now. To create a heat map, we need to call this function called geom_tile. So in the x-axis, we have the year, and in the y, we have the origin. And if we just run it now, it won't work as expected because we haven't specified what kind of values to use. We have two categorical variables, but we didn't specify the third numerical variable that we want to show, right? So in order to do that, we specify a fill attribute with average horsepower. And if we run this, we get the following results, right? So for USA in 1970, we have average horsepower of 166 and so on. And just one point here in the x-axis, the formatting of the label seems to be off. So let's fix that. by saying scale X to discrete. Now this looks much better. So it seems in USA in 1970 we have on average 166 horsepower cars. The next one I want to show is the histogram. Like this is the, I think, the most common plot that you will frequently create. And this is also absolutely easy to create using Let's Plot. Let's plot a histogram of horsepower. And this is all we need to create a histogram, right? And the default parameters here can be overridden. For example, if I wanted to, let's say, create the histogram with less number of bins, I can say bins equals to 10, and this looks much smoother than before. The next one is called box plot. This is also another way to visualize the distribution, but you can visualize these multiple distributions, not just for one. So let's visualize the distribution of the horsepower for every origin. So in order to do that, we need to call this geom box plot and add a new layer. And if we just run it now, we can see that in the x-axis we have the origin, and in the y-axis this box plot was created. So this thick line means the median value, and we can also see the minimum and maximum. So this also gives us an easy way to analyze our data. And if we want to add a little bit more spice into this, we can also specify the color aesthetics to be derived from origin. So now we have the colors based on the origin as well. We can also override this instead, the fill instead of the color. So this another one is called Violin plot, which is also used to visualize the distribution. As before, we define our base layer and define the aesthetics. So here we are again plotting the horsepower, the distribution of horsepower for origin. And there's a layer called geom Violin, which will give us the Violin plot. So this one gives you some additional information about the data. Here, for example, in Europe, the peak is at around 73 horsepower. And for Japan, it's 70, and also in the 90, 93, 95. So this was something not possible here in the box plot, but using Violin plot, we can easily see these different kind of peaks. The final one I want to show is something called dot strip plot. So if you want to show the actual values or the individual values in a plot, then you can use this. So instead of using the histogram to bin your data, or box plot or Violin plot to show it in a condensed way, you can plot the individual data points. So again, we define our base layer, and then we just call the geom point function. So here what we did was, on the x-axis we plotted horsepower, and in the y-axis we have the origin. And for every origin, it will the values are plotted. And we also colored the points by the origin. So this is also another way to visualize your data. Let's add a little bit of noise using this jitter function. And if we just run it like this, we can see that the points are now placed a little bit randomly, but this seems to be too much. I think 0.06 might be enough. And also using the alpha so that we can see the points that are behind each other as well. So you can use this dot strip plot to also convey the distribution of the data. And adding a bit more jitter and reducing the opacity of the points also helps to see the underlying points more clearly. So this is all I wanted to share. Let me know if you found this useful. Thanks for watching. See you next time.